Hello everyone and welcome to the very first episode of Tech Tuesdays with Kashu. And in today's video we will discuss the very basic electronic components, their uses, their functionality and their application. First one here is the resistor. A resistor is used for limiting the amount of current flow towards or out of a point in an electric circuit. Then we have the inductor. An inductor stores the electric current and discharges it when needed. Then we have the diode. Diode actually restricts the direction of current in one direction. Then we have the capacitor, which stores the electric charges. By doing so, it generates an electric potential between its positive and negative terminals, and it discharges when a load is connected between those two pins. So the capacitor, the inductor and the resistor, all three of them come in both fixed and variable types. The ones I have here are actually fixed types. Diode on the other hand have a lot of different types, which are Schottky and Xeno diode and a lot more types based on their functionality. The one I have here is a Schottky diode. Note that I haven't included any BJTs or MOSFETs or ICs or all those other things in this video because they are actually made out of diodes that we have here. So diode is actually a basic component, not MOSFETs or BJTs, and we will construct our own BJTs and MOSFETs out of diodes in future videos, but this video is just about the basic components and their functionality. So now that you know all four of them, let's just test them and see if they satisfy their basic functionality. So let's start off with the resistor. We will use this resistor to limit the current flow towards an LED. First we will plug this LED in the breadboard. Now let's connect the resistor to its positive terminal, and now let's add headers for the alligator clips. Now let's connect the power supply, and as you can see the LED is glowing. And you may be telling yourself right now that meh, what's the difference if I use a resistor or not? Well, let's see. And just like that, it's dead. Which brings us to the capacitor. So as we have said earlier that the capacitor stores electric charge and then it discharges it when you need it to. So keep in mind that the capacitors are actually polarized. You can see the negative side here and the black one is the positive side. So this is the positive side of the LED. So we will hook this capacitor's positive terminal over there and negative over here. And using some connecting wire we can complete the circuit just like that. And just add the header over here. You don't need to add a header on the negative side because you already got this exposed wire here. So let's see. So let's just connect the power supply and then we will see if capacitor actually gets discharged through this loop. Here we go. Okay, the LED is lit, and now when I remove it, boom, it's still on. It means that the capacitor is getting discharged in this loop here. And now let's test diode to see if it really allows the flow of current in one direction. So the white stripe here indicates its negative side and the other side is positive. So since this is the positive side of the circuit, let's hook it up here, the positive side here. So this is now the positive side of the diode and this is the negative side of the diode. So if I connect the positive terminal of the battery here, so then it's not allowed to let the current pass through the circuit and thus the LED will not turn on. So as you can see, the LED is not turning on. Now let's reverse the diode, put the negative here, and now on the positive side, connect the battery, connect the ground. You can see the LED is lighting up. So now the only thing that remains is the inductor. So the way inductor stores the electric current is by converting it into magnetic field around the coil. To see if there is really a magnetic field around the coil, when we introduce it to an external magnetic field, this should start moving. So for that I have a setup here. So to prove that we have this setup here are some permanent magnets, and here is this coil. This is one end of the coil, this is the other end of the coil, and they both are actually in contact with these bars. So if this coil does produce a magnetic field around itself, then in presence of an external magnetic field, this coil must start rotating. So let's see. Yeah, that is. So that's it for today guys. Thank you so much for watching and see you next week.